Our next talker is David Hustace, a former captain of the US Army and co-founder of OpenNMS in 2004. And today he will be speaking about the current state of OpenNMS and everything what's happening in OpenNMS currently. So, enjoy.
Thank you. Hello, guten Tag. That's about the extent of my German for those who know me. First, a little housekeeping. I'm not Jeff Gelbach. Jeff originally submitted and was scheduled to give this talk, but unfortunately couldn't make it. Jeff is arguably the newer version and better UI presenter, and arguably a lot smarter. Today, rather than just stand up here and pretend that I'm that smart guy, I thought I could relax a little bit and talk about what's going on with OpenNMS. As a matter of fact, I'm pretending to be smart. Wore these glasses, they don't even have lenses. A little bit about myself. Started this company with two other guys back in 2004, and we quickly realized that there were a lot of people interested in the project and started contributing. And we were a small company, mortgaged our houses, tried to figure out a way to fund this company, and recognized that there were a few guys that were contributing that we couldn't really pay. So we created this thing called the Order of the Green Polo, and some of those guys are in the room here today. Basically, the Order of the Green Polo was invented based on the Masters Golf Tournament and the Order of the Garter. So if you win the Masters Golf Tournament, you get a 100 green jacket. So we came up with green polo shirts that we could give out. And every year we invite them to a developers conference. So it's been a great experience for us. So it has been a busy couple of years. Last year, Toris Balog, my co-founder, presented here. I found this on his slides. And like all good presenters, weeks and weeks and weeks and weeks before this show, I spent preparing for this talk. Actually, most of last night. That's why I didn't join the dinner last night. But you can see here, in the last year, we've picked up 9 new contributors. We did almost 5,000 commits into the Git repo. And we've had 742 pull requests in the last year. Now, the way the development works in the OpenNMS community is that we have a pretty rigorous process for any time that a bug is created in the issue tracking system and the developer goes to fix it. We create a branch in the Git repo, and then we merge that when the bug is fixed. But we do that with a pull request, and one of the other contributors then review the bug to make sure it's approved, and then the developer merges it in. We have about 17,000 traps that come with OpenNMS shipped out of the box, already predefined, as well as about 2,500 performance metrics. So if your OpenNMS finds a node that supports those metrics, you'll automatically get graphs for those. Something we recently did in August when we released Horizon 18, I'll talk more about Horizon and Meridian later in the presentation, but we have an opt-in now in OpenNMS. So when you install Start to Web UI, it presents you with an option to opt in and send in some metrics. You can view those metrics, and basically it's just general summarized information about how many nodes you're monitoring, what kind of nodes, like system by system object ID, as well as what operating system you're running OpenNMS on. Now, of course, your instance has to have access to the internet to report it, so we're probably capturing a small percentage of the users that are actually running OpenNMS, but just since August, we've had 5,000 unique installs. Of those installs, they're monitoring about 360,000 nodes, about the same number of IP interfaces, which seems to be server-centric in this case. Services on those interfaces, about 700,000. That's like ICMP, HTTP. And then just switch ports, I guess this is, about 3 million physical ports of those on all those devices. Okay, so kind of a timeline here. We decided back in 2014 to change the way we release OpenNMS and split that into two projects. The way the OpenNMS group actually sustains itself is through commercial services like support, training, sponsored features from our customers, and consulting. What we were finding is that we were slowing down innovation in the project because the same code we were releasing to the community, we were trying to support with our customers on an ongoing basis and give them a long-term supported version. So sometimes we would get contribution, it would come in the form of a patch, we'd look at it and we go, I have no idea what this is going to do. It's not unit tested. I don't know what to do with it. So it would sit there in our issue tracking system forever and never get contributed. We'd also be doing these sponsored projects that I told you about, maybe 2 or 3 at a time for different customers. And then we'd try to find a way to merge that and make a stable release. And then we'd tell all our customers, we just released stable, don't install it till we know that it's stable. So I think this is the same problem that Red Hat found in the early days, so that's why they split off Fedora, and I guess at that time it was called Red Hat Advanced Server, now RHEL. So Horizon for us is like Fedora, and Meridian is our long-term support version, and what we do is we try to release as early as often, like the open source mantra calls for, with Horizon as quickly as possible. About once a quarter we have a new Horizon release. Once a new Horizon release is made, so after 14, we had 15, and Horizon 15, all new bug fixes go there. 14 is done. We don't go back. With Meridian, however, we do have long-term support, and by default, it's 3 years. So we created a foundation branch, and anything that affects the current development release as well as Meridian, we put those fixes in foundation, and they percolate their way up into those releases. I'm just going to kind of go through some of the major features that came with that in this timeline. Probably not significant to you, but significant to us was Java 8. There was a lot of improvements in Java 8 that we were able to take advantage of, a lot of scripting framework stuff. Shoot, I can't even think of them right now, but some concurrency things. But it was significant for us. We improved our link discovery, so instead of simply looking at bridge tables, we also look at CDP, LLDP, OSPF, and IS for getting relationships. We also introduced a Jmx configuration tool that runs from the command line. That was interesting to me, or ironic to me, that for a long time OpenNMS was a monitoring system that couldn't monitor itself. That being a Java application, you need Jmx for instrumentation, and that's finally introduced in Horizon 14 2 years ago. We also put these donut status charts on a geographical map. It looks something like this. I was going to do a demo for you today. As a matter of fact, I'm trying to relax as much as possible. I'm not like Kelsey Hightower with Kubernetes, get in there and do the live demo. So I've just made a few videos that will show some things, but I didn't make a presentation I didn't make a demo for geographical maps, but it looks something like this, and I think you kind of get the idea. You may see it in one of the videos as well. We introduced an operations board. So one of our customers came to us as a large online pizza company in the United States, and they had just redone their operations center. And they put 4 huge screens up on their walls, and what they wanted was OpenNMS to be on those screens, but they didn't want it to cover all 4 screens. They had things they wanted to show. So we wrote a rotating operations board that they could put up on one screen, and they could select what they wanted to see rotate through on that operations board. Of course, they can look at it on their desktop as well. The web app container, we upgraded to Jetty 8, and that along with Java 8 also gave us some better security. We introduced Bootstrap for theming the UI, which helped separating the look and feel of Meridian from Horizon. And we introduced a measurements API, which was very significant. It's traditionally very difficult to get data out of RRD files. So the measurement APIs serve 2 purposes, and you'll see those in some demos today. The measurements API is REST-based, and you can query OpenNMS's REST interface to get the telemetry data out of the RRD repository. You can also switch over to another persistent strategy. As long as you're using the REST API, you can get that same telemetry data. That measurements API became the foundation for being able to do other cool things like integration with Grafana. If you're not familiar with Grafana, Grafana is an open source dashboard that allows users to configure their own charts and arrange them in their own way. And we wrote a plugin about 1.5 years ago that integrates with Grafana, and it's a pretty significant thing for a lot of our customers, and it was the plugin is done and designed very well. And I'll show you a demo on that here, if I can. Let's see. I think I had a... Hold on a second. Let's see. It does say there's a link there. Let's try it again. Huh. Maybe it can't find the link. Let me see. I'm going to put the real glasses on. So just going to let that run. So basically with Grafana, you can log in, create your own dashboard. I'm going to create one here called OSMC. Can't see that here, so I have to look up there. And then add a graph panel. And when you do that, it automatically populates a graph with just fake data. So I'm going to go in and redefine the definition of the graph, give it its sizing, and then I'm going to put some attributes on the graph. So I'm going to switch to the OpenNMS data source plugin, add an attribute, query the REST API, look for a node. This happens to be a router called Mr. Mackey in our office. VLAN interface here for our WAN link. Go get an attribute like IFN octets. I think you're probably familiar with that value if you've done SNMP in your network monitoring. And then it automatically is populating the graph. We also added support in our plugin for filters. And the filter, one of these I just added here was an outlier filter, so it would clean up the data before it sends it back to the UI. And we also have integration with the R project, so we had a filter that we called trending, so you can automatically add trend lines to the graphs. So when you query the REST API, you can ask for a trend. And the trend and the query interface or the REST interface supports different attributes for those smoothing algorithms like seasonality and that kind of thing. So now here I'm just kind of cleaning up the UI. You can see there's a nice polynomial order drawn trend line on there, and just going to add some things to the down at the bottom there to show a table of what the min, max, and average values in the legend. Now Grafana has a pretty cool feature in it that you can just quickly duplicate. So you can say, oh, I want to duplicate this metric, and then all I did without doing any query, I could just change the name of the attribute or the name of the attribute of this particular resource to out octets. And then I'm going to change this filter to an expression. Our REST API allows you to put in a mathematical expression as well. And here I'm just going to invert it by saying multiply times minus. Does it say -1 or -8? I can't remember. -1. Okay. So that'll draw that. Should put it on there as a negative value. You can also, through Grafana, put in some nice date ranges, hit apply, and there you go. So you have trend lines for the in and out octets, and completely integrated with Grafana. Now, the nice thing is you can have multiple data sources on your dashboard. So not only can you have multiple OpenNMSs running and putting metrics from them either on a graph or in separate graphs, you can also use data sources in other places in your organization. So graph from OpenNMS, graph from Isinga, or any other application that supports the Grafana interface. Let's see if the link works. Well, that's not going to work. The backlink's not going to work because I didn't get there from there. Let's see. Sure, that makes this more fun.
Did you pick up the data from OpenNMS with Graphite, or did you export the data and graph it in Graphite?
What's Graphite? Just kidding. Interesting story about Graphite. I've been in network management a long time, but one of our customers is Sears Holdings in the United States, and the guy who wrote Graphite was working for Sears at the time. This was maybe 2006, something like that. And he called and said, hey, we want to use OpenNMS because it has a powerful data collection engine, but we think your graphing sucks. So could you write something in OpenNMS, we'll sponsor it, that will export the data as it's collecting, and I'll write a receiver. So that's when we wrote the Google protobuf integration with OpenNMS that will stream the telemetry data to a receiver. And then he did that, took that data, stored it in Graphite, and graphed it in Graphite. We're not using Graphite here. We're still using RRD, right? So the REST API just sits on top. And so when you make queries, we look either in the database for inventory, and then when you've picked your resource you want to graph, then we go to the RRD and pull the data out for you using our RRD tool integration, and then we pop it back in as a JSON result in the REST API. Okay, where was I? Okay, so 16 came, and we introduced newts. Now, speaking of RRD, one of the biggest problems we've had with OpenNMS, and probably spent way too much time on this, is persistence of telemetry data. When you're collecting millions of pieces of information from data all over a network, OpenNMS has installs of up to 30 or 40,000 nodes, right? So it's trying to grab that data from all those nodes and get it into a repository. RRD is very disk intensive, right? So RRD tool was designed for graphing, not for high performance persistence. So once you get the data in RRD, it's very easy to get it back out on the screen quick, right? But we have written a lot of infrastructure to try to improve that. So one of the things we did is we wrote a queuing mechanism so that we could optimize the writing into RRD, so if the persistence got behind the data collection, it would store up all those operations, and if I had 30 minutes of data to write, it would write all that data at once to that RRD rather than single transactions. Another thing we did with that queuing mechanism was about 0.01% of the data you collect is actually what you graph. But if somebody wanted to see the data that was sitting in a queue that's 30 minutes behind, when somebody clicked the graph button, it would send a message or an event into the persistence engine to say, promote this data now and write it now. So by the time the UI graphed it, it would be there. So it was a lot of work that we were doing to try to overcome the obstacle of getting data to disk. Now SSDs and some storage technologies got a little better, and RRD also itself got multi-threaded, so we updated our libraries for writing to RRD take advantage of multi-threading. But still, once you've bottlenecked the disk, there's nothing else you can do. No matter how many threads you're saying to send data, it's gonna stop there. Well, that's cool. I'll talk to you about that after the talk. But one of the things we said is it's still not linearly scalable, right? And we have a lot of customers with operations and data centers that we thought, well, we really need to take on a more data-centric view. So we invented a project called Newts. You can go to newts.io and check this out. Newts is a big data persistent storage built on Apache Cassandra that instead of writing to RRD, we write it into Cassandra. We built our own schema. I'm checking my time. We built our own schema so that you could get the data. We built our own schema, and you can now scale your persistence linearly without having to worry about trying to get a server to write data as quickly as possible. So if it gets slow, you can just install another Cassandra instance in your cluster, and you've just increased your storage capacity exponentially, as well as you're getting HA, right? So you have a high availability in your storage now, as well as being able to have multiple OpenNMSs point to the same storage without having to use something like NFS for your RRDs. It replaces our RRD tool, like I said here. Yeah, thank you, Toby. And we also had a Java version of RRD that people would use if they didn't, like of the maybe 1 or 2 users in the world that run OpenNMS on Windows, we didn't have to do binaries with for that platform. So some of the challenges. When you get rid of RRD tool, RRD tool brings a lot to the table. So obviously persistence, right? You need to be able to store. Graphing came with RRD tool, so we had to get our own graphing. Drawing, that's the drawing part. You need a query language for getting the data out, so users can actually know how to define a graph and ask for data, and that is the graph definition language. So a really cool thing we did with OpenNMS is we said we want to abstract that away from the user. So we continued to keep the same query and graph definition language that RRD tool uses, and we support that going in to get the data out of Cassandra. So you don't have to go redo all the graph definitions in OpenNMS. Just keep using the same ones you have. We'll just get the data out of Cassandra instead of the RRD store. The project we created for graphing, and we still use the same graph style, is we created a JavaScript tool for graphing RRD like graphs that are defined in the RRD graph language. I'm going to try this again. It doesn't seem to want to work. It's not working. I don't know why. So I do have a demo of that. There we go. Okay. Is it running? Yep, there we go. So that's the OpenNMS home screen. I queried for the same node that I showed you in Grafana. Look at that cool video editing that I did. Pick the same interface, pull it up on the default OpenNMS. I think I sped this up a little too fast. But same interface, same data. Now here's the same graph, but this time it's drawn with backshift, and you can see that it's more interactive, right? It's JavaScript, so we can scroll right there inside it without having to, just try to do crazy, clever things with an image. And we also show you the data behind it, so you can copy it out and paste it into Excel or something like that, right? So we've automatically formatted so it'll fit into a spreadsheet. We also can do this graphing in real time. So if you're trying to diagnose something while you're looking at a graph, you can say, show me in real time, change instead of the default interval every 5 minutes. I changed it here to 5 seconds, and you can see it's collecting the data. And it's compressing right now, but once it gets to 2 minutes, the data will start sliding off to the left. There it goes. And then you can go back and turn compression back on if you want. And all that graphing is done in JavaScript. We also support the trending and forecasting in the user interface. So here I am. I'm coming in, picking a seasonality of a week, and I said, so that went pretty quick. So what I did there was I said, this was a graph to show me for a week's worth of data. But when you do trending, you need a lot of data. So I said, go back 120 days. Get all that data, and then I want to show up to the last 30 days in this graph, and then I want to predict, I think I put in there one season, which was a week. So I had 7 days in the seasonality. Seems like in most of our customer sites that the seasonality of data, Wednesdays look like Wednesdays, Thursdays look like Thursdays, Saturdays look like Saturdays. So, and here I said, I also want you to draw the trend line as if I would have predicted it 30 days ago, right? So I could see how well our prediction algorithm is actually working. So that's the blue line there, that prediction, showing how we would have predicted it if you were looking back 30 days ago. So I could know how much confidence I would have in this prediction line as well as the trending there. looking out to the future, so I can be confident. And those red lines are confidence bounds. But you can even see that the trend line shows that the data utilization is going down on this interface. I don't know why the clicking's not working. I think it's got something to do with the two displays. Where were we? Back to the real glasses. No, that's not it. There we go. Okay, so to get that analysis, we integrated with the R project. So we wrote some JNI code and that kind of thing to be able to call the algorithms that are contributed from statistics geeks into the open source R project. OpenNMS also has a reporting engine, so if you want to do like Crystal report style reporting, there's a project called Jasper Reports. We embedded the Jasper reporting engine in OpenNMS. You can use Jasper Design Studio, and you can query our database and our measurements API through a Jasper data source that we provide. And you can define your own PDF graphs, HTML graphs, whatever, and have those run on a schedule and emailed to you. But we updated it in Horizon 17 to take advantage of newts. We also have heat maps inside OpenNMS. I was going to do a demo of this, but this is pretty simple. You can, with a heat map, you can kind of find places and drill through there that you weren't able to see just looking at like a list of events or something like that. We put in single sign-on support in this version, and for Kerberos authentication or Kerberos tickets. We now moved Jmx configuration from the command line to the web UI. And we created northbound interfaces. We had a project with Dell where they embedded OpenNMS in their cloud-in-a-box solution, and they needed northbound APIs for the customer, and we went ahead and implemented those for them. Integration with Otrs was upgraded to 3.1 plus. And we have a very nice ASCII documentation framework. One of the banes of OpenNMS and probably most, this thing keeps falling off, most open source projects is documentation, but thanks to contributors like Ronnie Traumer, we now have a really nice ASCII doc-based documentation project that runs right alongside with the development. Part of the development process is to, if it's a new feature, when a reviewer reviews your code, you have to have documentation as well. And the nice thing is the documentation is versioned with the project. In 18, we also updated topology icons, as well as the user being able to right-click on an icon and say, I want to change this icon to some library of icons that are in OpenNMS. And we introduced business service monitoring. This is another demo that's not going to work when I click on it, but I'll show it to you anyway. But just to explain, business service monitoring was sponsored by the United States Patent and Trade Office. They have an amazing amount of infrastructure that they monitor. They want to be able to look at things at a higher level of abstraction. They want to be able to see things that represented as services that the lines of business provide, and only be notified when those services are impacted. No, this is not going to work. I'm not even going to try. Let's see. There we go. So the business service hierarchy is displayed in our topology framework. So the topology implementation in OpenNMS has a very nice set of APIs for putting in any topology. And in this case, we put in a business service topology. The OpenNMS topology interface is focal point driven, and when you navigate to it, if you haven't specified, like from another place in UI, clicking on a link, a focal point, then it picks one automatically. In that case, it came up with one, but I changed it by searching. I searched for the blog business service. The business service icon looks like these little briefcases, and we're now navigating. There was a saved version of the layout, so when I clicked on that saved version, it restored that layout. I can now change it. I didn't like that alarm icon sitting off there, so I can move it over, hit save, and it'll persist it that way. Now, some of the semantics about the interface is that you can change the number of hops away from the focal point. So I think, did I do that? No, I think I switched layouts or something to show that I could restore the layout there. So I can increase the zoom. So I zoomed out in terms of hops away from the focal point, and I went to 4 hops away, and it now is showing all the alarms in the system. I'm also able to zoom to the focal point. Over there on the left has that little indicator to zoom to it. I can hit the global view and it'll zoom back out. And I can also hit this, what I call the magic eye button, and it'll reveal which icon is the focal point of this particular set of this context. And we built a simulation mode. So one of the things that we did is, how do we represent status up the hierarchy? When alarms are happening, I need to be able to propagate that status up the hierarchy in a way that makes sense and give you some fine-grained control. And what we did is we introduced a map-reduce technology. So when an alarm happens, you can come over here and you can see I'm using a mapping function that says map identity. So if this is a warning, it's going to map it as a warning up into this service, and that service has a reduction function. So if I'm getting multiple inputs, how do I decide which one of those inputs to use? So it's a map-reduce algorithm. And you can see that it did percolate up here, and on this, on that edge there is a mapping function that says, if this is whatever alarm this is, I don't care what it is, I'm going to set it to critical or major. So that's why it changed from warning here to major, and that's why, and this one says take the highest severity of all these, and so it's major as well, and propagated it up to the top. Now, you get alarms every time a business service changes its state. So instead of watching all these faults down here, you can just be watching for business service alarms if you're the owner of that line of business. So what I'm going to show you here, we also implemented root cause analysis and impact analysis in the UI. So if I had navigated from an alarm to here to show that the blog service was in a severity state, then I could right-click on it, I could say, show me the root cause, and it'll drill down through that hierarchy, however big it is, and show you what alarm is causing this problem for this business service. And you can go the other direction. So this is forward and backward chaining. So what I did was I removed that, made this the focal point. I said, if I'd come here from the alarm, tell me what business services are impacted by this alarm, so I can say, do impact analysis, and it'll go the other way. What alarms are causing problems with my business service? Is that it? I think that's it. Now back to where we were. I think that's it, yep. So that was in Horizon 18. We also have Elasticsearch Integration. So alarms and events that are happening in OpenNMS, no matter where they're coming from, also get pushed into Elasticsearch, and you can do forensics on your event alarm data, which will be traps, syslogs, other logging data that are coming from the systems that are reporting into the NMS, as well as the alarms on top of that. We have notification in engine and OpenNMS that has fairly complex workflows. So, initial targets, escalations, all those kind of cool things. We also do Slack and Mattermost notifications, as this was a plugin that was introduced in 18. We have a third-party licensable plugin manager. So if you want to write something in OpenNMS that you don't want to open source and you want to sell it, and we have some vendors that embed OpenNMS and they do this, we have a licensing infrastructure, a licensing plugin infrastructure in OpenNMS for doing that. We have a scan report. So this is something that a customer of ours that has a lot of branch offices needed to be able to give to salespeople when they were out, as well as technicians, so they could go to a customer site, go to the OpenNMS web UI, and say, run a test from here to make sure the applications work from this customer's network. and it lets them, I wish I had the demo, but it lets you pick what applications you want to test. It runs through that test and it gives you a red X or a green check mark. You can also, if you're a technician, you can twiddle and you can see what the problems were and all the response times for all the things you were testing. But at the same time, publishes a report on the OpenNMS server that the operations center can look at. So this is a remote diagnostics tool and it's all runs in the browser. You don't have to, it runs from the browser. You don't have to really install anything or take anything with you. We have IBM TSRM integration, the usage statistic plugin that I talked about a minute ago, and we have another demo, Project Atlas. So one of our customers came to us and said, you know, LDP, BridgeMib, ISIS, all those technologies you use to discover topology are great, but we have a topology you can't discover, but we know that topology. And it's a very large network, and we don't want to sit there and draw things. We have it in our CMDB. We need an API for getting that in OpenNMS. And that's what we call Project Atlas. And I have a demo. Same story, different day. Okay. Let's see. Atlas, there we go. So Atlas, again, is integrated with the topology. And let's see, how did I do here? So this is the default topology, but what I'm showing you here is that with OpenNMS you have all these different topologies that you can look at, but the Atlas or the one defined for an Atlas project was not there. I was going to show you how you can do this dynamically. So the graph is defined in XML, and there's a REST API for getting that graph in OpenNMS. So from your CMDB, you can program this graph directly as changes are happening. So I show you here, I'm just using curl to push that in as one single document. And then I go back to the OpenNMS UI, I think. I was just going to show you where that lives. So once you push it in the GraphML directory, this GraphML is a spec for how to define graphs in XML that we used. It was a standard. So now when you go back to the UI and look for you'll see that there's a BigNet topology. And when you click that, it'll switch to that topology provider. And then now it goes through this hierarchy-based, and Atlas lets you define hierarchies or layers of topology. So when you click the little hamburger menu there, you can see all the different layers. So I had areas, bazaars, pops. These are all just made up things. But I go to Champagne and go into the pop in Champagne. Show me the pops in Champagne. And then I can go to the OpenNMS 100%, very millennial. And I drill into there. And as you can see, as I'm clicking Navigate to, it's going down through the layers, but only in the context of that location. So now I'm in the racks layer, and now I have a topology that was provisioned from Atlas. So here's the source and here's the target. So your GraphML will allow you to define what topology looks like in your what you want it to look like. Now you can also manually change this. So once if the layout provider didn't pick a layout like you wanted to see, you can still move it around, hit save, and it'll save it the way that you want to see it. Next time you navigate here, it'll be this way. I think that's it. Yeah. Okay, where were we? Yeah. So that's still Horizon 19. So 19, I guess looking at that date there, you can see is scheduled to be released this month. So right now we're quite busily working on the last minute bugs, and there's a few little blockers. If you go to the issue tracking system, issues.opennms.org, you can go to Project Horizon, and you can see what blockers are left. There's 2 or 3 blockers left that we're working on. We also have a really exciting project in OpenNMS called OpenNMS Minion. Minion is a distributed framework for OpenNMS. It's a stateless little microservice piece of technology that you can put in branch offices and locations that you can't see from your data center. This thing keeps falling off. So you put Minion out in your branch office, and then OpenNMS, when you decide to say, I need to run discovery, it sends a message to that Minion. The Minion actually logs in and checks to see if there's a message for it on an interval. When it sees that it needs to do a job, it goes out, does discovery in the branch office, pushes that data back to OpenNMS, and it gets published just as if OpenNMS had done it itself. It's completely stateless. And Minions don't need to know about each other. You could put 2 or 3 in that office, and they all work off that competing consumer-style queue. If one falls off, the others just keep working. And I do have a little bit of a demo for that coming up. Histogram status boards. These were style status boards were introduced, so now you can put your own little histograms up on OpenNMS's UI, and you can configure these yourself. And the future is bright, so I'm looking at Horizon 20, which is sometime next year. It's a big project. We have a couple of customers that are sponsoring things like NetFlow integration. So now when you're looking at a bandwidth graph, we have a little prototype. You're looking at a bandwidth graph. You can click on that bandwidth graph that maybe had some threshold or high utilization and ask for all the conversations. What caused this bandwidth to go up, right? Who was talking on the network and what protocols are being used? We're also writing a management console, so a service layer on top of multiple NMSs with a console on top. And we're making OpenNMS HA. Just to show you a quick timeline on Meridian, you can't really read that, can you? All this time I'm looking. So that is, I'm going to use my glasses. March of 2015, and that was based on Horizon 14. Right, Ronnie? Was that right? Horizon 14. So basically, once Horizon's been out in the community for long enough, or the features in that have stabilized, we backport those, put them in a Meridian release for our customers. And we do that once a year, and then we do updates throughout the year on that release. So Meridian 2016 was released somewhere around May, June timeframe, and that was based on Horizon 17. The next release will be in March, and that'll be based on Horizon 19, which was out this month. There's a few other features that I didn't have time to put a demo together, but in the topology map, we also have now a plugin on the side that lets you write your own plugins in the information panel. So there's a scripting language that lets you, if you click on an edge or a vertex in the graph, you can put your own information up on the info panel. One of them that we included in the project is if you click on a node that has latitude and longitude data or an address in it, it'll put it on a little OpenStreetMaps image on the side there, which is fully navigable inside there. We also have support for Open Daylight as also as a proof of concept. So we can talk to the Open Daylight controller, learn about all of the virtual infrastructure in your Open Daylight virtual network, and pull that into OpenNMS. We also can talk to VMware and learn about your VMware systems, pull those in. And each of those are different topology providers in OpenNMS with infrastructure for monitoring underneath. And the future is not really bright, it's actually a bit cloudy. So the 90s called us and said they want their GUI framework back. If you've ever used OpenNMS, I don't think that the GUI has changed much since 2000 other than restyling. This was Microsoft's UI back in 1999, which isn't really too much different than our UI, right? Little menu at the top kind of thing. And you can see, as of today, Microsoft's website looks much different, and so should ours. So we're also implementing a project called OpenNMS as a service. Now, this is an offering that the OpenNMS group is going to have, but it's going to be built on cloud infrastructure for OpenNMS. So if you're running your own cloud infrastructure in the data center, such as OpenStack, you'll be able to deploy OpenNMS as a scalable microservice solution in your own data center. we're going to do this also as a service for customers that don't have a data center or are tired of running their own NMS. That little Minion thing I talked about, they'll either install a software version, and we also have a hardware version that you can purchase and put inside your environment. And then you just come to OpenNMS as a service UI, and you'll be able to look at all the monitoring data there without having to run your own NMS. And we'll maintain that for you. So we use a microservice architecture that was vetted by the work we did in Minion. We're also moving that into OpenNMS. We orchestrate with Kubernetes, and we use our container technology is Docker, and our public cloud offering is built on AWS. So the Minion communications look something like this. I won't bore you too much with this because I want to save a little time if anybody has questions. But the way it works is the Minion sits out on the other side of, say, a firewall. You just need to open a port so that the Minion can talk JMS over secure connection back to OpenNMS and get its work to do. And that's how it also publishes its data back. Our solution right now, we have a little virtual private cloud because we haven't hardened the infrastructure. So when I show you the demo, you won't be able to go to that URL and try it without making a connection to the Oz VPN. But once we finish and we begin to offer it, we'll remove the VPN so the public can get to it. So that's the VPN infrastructure, and here's what Oz looks like. So the graphs or the vertices that have the little dots, those are microservice based, so they can scale on demand. And you can see here that the one that's not, right now in our prototype, the arrow doesn't work. Maybe that's why the demo thing's not working. But is OpenNMS and Postgres. But we have taken ActiveMQ, made some code changes there, make it run as a fully meshed cluster. You can we can add and remove ActiveMQ brokers on demand, and because we fully meshed it, there's never more than one hop in that cluster from broker to broker. And then as it scales for OpenNMS, instead of scaling linearly as a microservice, we have if another customer wants to create an instance, then we create an entire new OpenNMS container. So, in 20, what we're working to do is make that fully microserviced, so that instead of saying OpenNMS, it's really OpenNMS is more of a service layer where we'll have pollers and data collectors and all the infrastructure in OpenNMS as microservices. This Slinger guy here, down here, he's the guy who actually uses a Kubernetes API to spin all this stuff up. And I know the demo's not going to work, so I'll just go. I'm getting close to the end if you're getting hungry. So I also have my iPhone connected here. You can see I'm connected to the VPN. I had the iPhone up so I could show you some pretty cool integration there. While I'm thinking about that, we also have a mobile app for OpenNMS called Compass that didn't make it into the slides for some reason. So you can bring up Compass and acknowledge alarms, escalate alarms, look at graphs, all that kind of thing. And so in the microservice, or in Oz, what we're doing is here, I've logged in, it's logged into an instance that was already existing using my account, so it didn't have to create it. But it does say, hey, do you want to start a Minion on your phone? Now we call this project, what do we call it, Ronnie? Underling, yeah. So Underling is written in Golang, and we've made it to run on Android as well as iOS. And you can just point it at, it looks like a German word, doesn't it, Underling? So you can just point it at that scan code, and it starts the Minion on your phone. And if you're connected to your network with your phone, you can do all the discovery and polling and everything right there from your phone. So again, this is all prototype. This is kind of mocked up stuff. There's actually an instance that is running. You can see that there's one alarm, and we just made it to put an alarm in the database. You can see you could browse from the higher level console. Because of the introduction of Minion, we also had to introduce locations into the model. So alarms that are happening, you can look at alarms or performance data specific to a location. Now this was some integration we did so that you can see that we're still using the same URL, if you could read that, for everyone. So it's just like if you went to salesforce.com and logged in, you get your customers. If you go to oz.opennms.com, you get your instance of OpenNMS based on your login. And we're using auth2 or auth0 for the authentication. I'll show you that here in a second on this demo. But you see we've popped out your instance of OpenNMS. If you need to drill down below the higher level console, you can still do that. What are we doing here? Okay, so that's just kind of where if you need to go to get the scan code yourself again, and then log out. So this time I'm going to log in, but I'm going to log in with a different account. What am I doing? Oh, I was going to show the Kubernetes integration. So any Kubernetes experts in here? Oh, thank goodness. My knowledge is very small. Anyway, some commands that I've learned to go check on the status of things in the cloud infrastructure using Kubernetes. So you can look at the deployments, you can look at the services that are deployed, and then at some point here I show auto scaling, which is probably just going to be way too hard to read. If you want to take a look at this with me after the talk, I can show you personally how that works. So I just started a kube proxy there, so just going to localhost on port 8001, I can browse right into the Kubernetes infrastructure there, and we can look and see all that we were looking at the command line from the Kubernetes console. So Kubernetes provides some very handy utilities for tunneling through without having to expose that console to the public. Let's see, where do I go from here? I was just showing some navigation within Kubernetes there, but you can see, if you could read this, you can actually see the host name and the IP address of this particular pod that's hosting this service inside AWS. Okay. I think the one thing I wanted to show you was the auth0 integration. I don't remember what. I think this is the scaling of the deployment. I wish even I could read that. I bet you I used to be able to speed that up. Oh, while this is doing that, I'm waiting to get the auth0 demo. I do have t-shirts. If you want a t-shirt, just stop by and grab a t-shirt. I have no idea what I'm doing there, so I've probably done it at midnight last night. But it's kind of a play on the Club Mott logo. OpenNMS, you get used to it kind of thing. Did we get there? Oh, there we go. So I think I'm using my GitHub account here, so I use two-factor authentication. And you get to see how tired I was because I keep trying to use my Google token and not my GitHub token. So finally I figure it out. Come on, wake up, try it again. And so now it's creating that instance in the cloud for this new account. And once that finishes, you'll see that there's now, I have to refresh the Kubernetes console, but now there's another instance of OpenNMS there running. I think I'm going to stop it there because it was late. I have no idea what I did. So again, back to DevJam, we do this once a year. We pay for all the travel and accommodations for all the green Polo contributors to OpenNMS. We usually have about 30 guys show up, or 30 guys and gals now that we have a gal that shows up. And we hack on OpenNMS for a week. It's really one of the best times of year for me. I just, I get to see all these guys from all over the world. We have people from Italy, obviously from Germany, from the UK. We've had people from New Zealand show up. It's really, really a great conference, and I think we just had our, what was it, Ronnie, 11? I think the 11th conference, maybe, 10th or 11th. Anyway, but we always host it at the University of Minnesota. Minnesota is one of these godforsaken places that in the summer it's about 40 degrees. In the winter it's about minus 20 degrees. So it's really not. If we could get there in the spring or fall, that would be great. But we use the university's dorms. And there's a real nice dorm infrastructure. We all stay in the same dorm. We go down. We have this giant club room, and it really has built a nice culture in OpenNMS. For me, having done this for 12 years, OpenNMS really is at this most exciting time. I think if we look at what's happening with technology today with microservices and cloud and things like that, these are really cool, interesting times to be in for technologists. And I think that's just, we're hopefully exploiting that as well here at OpenNMS. But OpenNMS has kind of been the basis of my life's work for the last 12 years, and I can't remember a more fun time while I've been doing that. One of our somebody snapped a quick photo at DevJam a couple years ago, and in the dorm they have all these cool things for the students to try to keep their attitude up and things, and David Slink, one of our contributors, was there, and somebody snapped a photo of him here. Believe in yourself, and I think that's what we've had to do all these years with OpenNMS is just believe in the project, believe in the community, believe in the open source, and it seems to be paying off. Not necessarily financially. That's it.
So thank you very much, David. I think we have 1 or 2 minutes for questions, if we have any. All right, so, yeah, again, thank you very much. Lunch